Hello everybody, we're getting ready to do 9.4 of Algebra 2 Math, which is inverse trig functions. This will be part 1. You want part 2, part 3. There might even be a part 4 to this lesson. I'm not sure. I think there might be. Email me and I'll get those out to you. 9.4 part 1. Here is your standard here. Evaluate inverse trig functions. We have a 32-point skill sheet here. And we have a 6-point notation guide. If you need that stuff, email me. Teachers, here's your bell work. Find the areas here. So you want to find areas of these pizza slices. Students, give your students 5 minutes. Okay, welcome back everybody. Here's the answer to number 1 up here. And then here is the answer to number 2, finding the area of a sector of a circle here. You could do it this way. This is an area formula here of finding a sector of a circle, and you get 49 pi over r, which is 19.24 square inches and 18.85 square inches for this piece here, using an area formula that was in a part 2 or part 3 of a previous lesson. If you're lost here, you need to get part 2, part 3s. Okay. So, moving into our 9.4, evaluate inverse trig functions. You found values of trig functions. You will find angles of given values from trig functions now. So far in this chapter, you've learned how to evaluate trig functions of a given angle. In this lesson, you'll study reverse, finding an angle that corresponds to a value of a trig function. Suppose you were asked to find an angle theta whose sine is 0.5. After considering the problem, you would realize many such angles exist. For instance, these angles here would be sine 0.5. All of these would be sine 0.5 here. All have a sine of 0.5. To obtain a unique angle such that sine theta equals, you want to restrict the domain of the sine function. Domain restrictions allow the inverse sine, inverse cosine, inverse tangent functions to be defined. So now we have to have domain restrictions, inverse trig functions. So here's an example here of -1 and 1. This would be -1 and 1 up here. Then the inverse sine of A is an angle theta written in theta equals the inverse sine inverse of A, where sine theta would equal A, and here would be the restrictions here. Negative pi over 2 and is less than or equal to theta is less than or equal to pi over 2, or negative 90 degrees and positive 90 degrees. So this would be a negative 90 degrees, and then this would be a positive 90 degrees here. This would be a theta for this. If -1 is less than or equal to A and A is less than or equal to 1, then the inverse cosine of A is an angle written of theta equals the cosine inverse of A, where, so this would be -1 cosine, this would be +1 cosine here. So cosine theta would equal A. And then here are our domain restrictions here for that. Less than pi, this would be 0, then this would be pi. And then again, here is another restriction for that in degrees. 0 degrees and 180 degrees. 0 degrees, 180 degrees. So, if A is any real number, then the inverse tangent of A is an angle theta written in theta equals inverse of tan, where tan is A. And then here are restrictions here, negative pi over 2 and positive pi over 2. And this would be your restriction on that. Okay, so if it's example 1, evaluate inverse trig functions here. So the inverse cosine function of square root 3 over 2 would be the angle whose cosine is radical 3 over 2. So you get pi over 6, or it'd be 30 degrees here for the inverse of this ratio here in cosine. So the sine inverse sine of 2 would be, there is no angle whose sine is 2, so the inverse sine 2 will be undefined. And then the inverse tan of negative square root of 3. So here it would be our restrictions here for that. Negative pi over 2 and pi over 2, or negative 90, positive 90. The angle whose tangent would be negative square root of 3 would be negative pi over 3, or negative 60 degrees would be that solution. Okay, our guided practice here. And students, this one is you. So we're going to do the first guided practice, evaluate expression in both radians and degrees. So negative, we're going to restrict this for negative pi over 2 and less than or equal to theta. Theta is less than or equal to pi over 2. Or negative 90 and positive 90 will be the domain restriction there. So it would be 45 degrees for this one here. And that would be it on a calculator. Solve a trigonometric equation. Solve the equation sine theta equals negative 5 over 8, where 180 to 270 would be our domain restriction there. To determine what in the interval negative 90 to 90 degrees. So we're going to find that first, and then this is what we get here, negative 90 to positive 90. So that would be this here. It would be negative 38.7. This angle is in quadrant 4. So that would be this right here. So the negative 90 would be here, the positive 90 would be up here. So negative 38.7 would be one of the angles that would satisfy this domain restriction up here. 180 to 270. 180 to 270 would be this. No, it would be in this quadrant here for 180 to 270. That would be quadrant 3. This is quadrant 4 here, and we show that here. Find the angle in quadrant 3 where 180 is less than theta, theta is less than 270. That would be over here. And that would be this angle right here. And that would be this angle here. As in step 1, the angle would be 180 plus 38.7 and would be 218.7. So that would be this angle right here. This is in quadrant 3. Use calculator, check your answer. So 218.7 equals negative 0.625, which equals negative 5 over 8. So it would check on your calculator that these two angles here satisfy what we're after for the sine of negative 5 over 8. Okay, in our next guided practice, cosine theta is 0.4. And then here is our domain restriction. Here is 270 less than theta, theta less than 360. Students, this is you. Tan theta is 2.1. Here's your domain restriction here, 180 and between 180 and 270. Okay, so we got to practice here. So cosine 0.4, the inverse of cosine 0.4 would be 66.4 degrees. Now it's got to be between 270 and 360, so that would be quadrant 4 is what it would be. So this would be it here. 270, 360 would be here. This is 270, this would be 360. So it would be 66.4 degrees, negative 6.4 degrees. So it would be minus 66.4 would be 293.6 degrees. So this would be, if you're doing this here, it would be 293.6. Or it would be a negative 66.4 would be that. I'd take that answer. Then 66, this is the positive side of it here. But we're looking for 270 and 360, which would be in this quadrant here. Okay, and this would be it on your calculator here. 66, and this is 113 would be over, see, 90. It would be up from the other terminal angle, from the 180 degree mark would be this measure here. Okay, so that was part 1 of 9.4. You want part 2, part 3, so you can keep up, then email me here. Thank you very much.